What's up, everybody? It's Mr. Doodle Math here, and today we're going to talk about graphing absolute value functions. And today specifically, we're going to look at some shortcuts as to how to graph absolute value functions, and we'll go into detail another day. But today we're just going to look at some key things to help us graph these absolute value functions, right? So first things first, let's look at the makeup of the function itself, right? So if we look at it, it'd be like y equals the absolute value of x, right? This is the absolute value function, right? Y equals absolute value of x, right? But inside of this absolute value function, what I want you to see is, well, first of all, let's look at this. No, we're just gonna go, right? So let's look at it like this. Y equals a, right? We're gonna put an a on the outside of absolute value bars, minus h, right? Plus k, right? What's going on essentially is in the absolute value function, you have two lines that are running into each other. They're going in the opposite directions, right? So they look like V's. Absolute value functions are V's. And so they meet at what we call the vertex, right? This right here is the vertex. When you look at an equation, the vertexes consist of h and k, right? H is inside of the absolute value bars. That's the x. This is the x of the vertex, and k is the y of the vertex, right? And so the way they show up is inside the absolute value bars, the opposite is positive, right? So the opposite is reality, right? So if it's negative on the inside, it's going to be positive as a coordinate, right? And if it's positive on the inside, it'll be negative as a coordinate, right? And I'm going to show you that in a second. Now, the k represents the y of the vertex, and whatever it is what it is. So if it's positive, it's positive. If it's negative, it's negative. All right? So that's the h and the k, right? So let's look. Basically, so that's that. I'm going to leave it here for a moment. Now, the easiest way to graph any function is to make a table, right? And the table is just like, it takes care of itself. Make a table, connect the dots, right? Now, let's look at this formula here, this function here, where it says y equals absolute value of x minus 2 plus 4, right? If you look at what I just told you, h would be the 2 because it's negative in here, and the k would be the positive 4. Therefore, the vertex is going to be 2, 4, right? And so what you'll do is you just start at 2, 4. This will be 2, 4, and then you will just continue going up. Right? You'll move. You keep moving. Now, we started here. We started at 2, 4, right? How do we get out of the points? If we're looking at this like this, you can look at this a term, right? This a represents the slope of your absolute value function, right? So in this case, there is no number here. So algebraically, we know there's a 1 there. So when we start at 2, 4, right? You go up 1, over 1, that's your next point. To the left, you go up 1, over 1. To the right, that's your other point. And what you'll see is that each side is symmetrical to each other. They're equal distance away from each other, right? And so what I wanted you to catch basically first and foremost is the vertex and the slope. That's all you need. The vertex and the slope, and then you graph. But with absolute value functions, you have positive slope and you have the negative slope to consider, because essentially this is two lines, right? And the two lines are stopping at the vertex, right? So let's look at some more examples of identifying the vertex. So if I had this formula, this equation here, y equals the absolute value of x plus 5 plus 7, right? H is negative 5, right, because it's inside, right? And k is going to be 7. So your vertex is going to be negative 5, 7. Bam, that's it. So the graphic, you'll start at negative 5, 7. This a is 1, so you go up 1 over 1, or 1 over 1, okay? Let's look at this next one. Let's look at this one. It says y equals 3 times the absolute value of x minus 4 plus 1. Again, the number on the left side of the absolute value bar has nothing to do with the vertex itself. It just shows you how this situation is going to move. It's the slope, right? This is A, this is H, this is K, right? H is 4, K is 1, your vertex then is 4, 1, right? 3 represents your slope. So you got 3, 1, negative 3, 1 for the second line, and that's how you move, right? Let's look at one more example here. Now, check this out. I have this situation here where it says negative 2, y equals negative 2 times the absolute value of x minus 3, right? Now, there's two things going on here. The A is negative. Since the A is negative, it's going to be an upside down absolute value graph, right? It's upside down, right? It's a negative function, so it's going to be upside down. Here, there's no H, so H is 0. The K is negative, so it's negative 3. So your graph would be starting at 0, negative 3. Vertex is always the starting point of the absolute value graph, right? And so that's what I wanted you to catch today. So if I was to graph this, 0, negative 3, 1, 2, 3, right? 3 on the y, 0, negative 3 on the y, and it's negative, so we're gonna go down. The slope though is negative 2, 1, and it's going to be positive 2, 1, right? So you're going to go down 1, 2, over 1, down 1, 2, over 1, right? So your graph would just run like that. And that's your graph, right? In review, we go to this one. I explained it, but I didn't show it to you, and I apologize. So if I was to graph this, 4, 1 is the vertex. So 1, 2, 3, 4, right? And go up 1. It's positive. So our slopes are 3, negative 3. So it go up 3. 1, 2, 3, over 1. That's going to be your first point. And then 1, 2, 3 to the left. These are equal distance apart. And so what you'll notice is that the y values will begin to repeat, right? Because basically this first point is at 4, 1. The second point is going to be at 5, 3 more. Hold on, 4, yeah, 5, yeah, 3 more. So that's 2, 3, 4, 5, 4, and it's going to be at 3, 4. They repeat. The next point will be at 3 more up and over to the 1, right? So essentially, that's what we're working with, right? To graph absolute value inequalities, absolute value functions, right? To graph absolute value functions, you want to identify the vertex, right? What's inside of the absolute, the number inside of the absolute value bar and the number outside of the absolute value bar on the right side gives you your vertex, it's H and K. The number on the left side of the absolute value bars gives you the way that the graph will move on both sides of this axis of symmetry, which is another term that we'll discuss on another day. Now, just take what I gave you and get to work, and we'll go deeper another day. Until next time, if you have any questions, comment below. If you haven't already, don't forget to like and subscribe. Mr. Do the Math out.